Hello, everybody. My name is Joe Sertich. I'm the curator of dinosaurs here at the Denver Museum of Nature and Science, and I'm really excited to join you all today to talk about something that I'm really passionate about, and that's dinosaurs from the southern continents of the world. And so you might be wondering why would a paleontologist who's based in Denver in the Rocky Mountain region, where you can go 10 miles from the front doors of the museum to dinosaurs of the Jurassic, or dinosaurs of the late Cretaceous, why would you go all around the world to find dinosaurs? And that's what I'm going to share with you today. And to do that, I'm going to have to share my screen. And so today I would like to talk to you about dinosaurs from Gondwana. Gondwana is the ancient landmass, the super landmass that today we know the continents of South America, Africa, India, Madagascar, Antarctica, and Australia are derived from. But when we think about dinosaurs from the Cretaceous, so if you were to transport yourself back 60 or 70 million years into the past here in Denver, this is what the world of the Rocky Mountain region would have looked like. So it would have been dominated by things like horned dinosaurs, tyrannosaurs, and duck-billed dinosaurs. But if you were to transport yourself to, say, Africa or Madagascar at this exact same time, it'd be a very, very different world dominated by a different type of meat-eating dinosaur called abelisaurs and big, long-necked sauropod dinosaurs. So a very different world from what we see here in North America at the same time. And to understand why we have this difference, we need to look at the map and what was going on with the continents. If we go all the way back to the very first dinosaurs, so in the end of the Triassic, all the continents were still united in the giant landmass that we know as Pangaea. So here is a great map done by Ron Blakey showing a conceptualization of what Pangaea would have looked like. And as we progress through time, you'll see the modern continents begin to form. So here we are at the end of the Jurassic. So this time here in Colorado, we had Stegosaurus and Allosaurus roaming the streets of what is now Denver. By the Cretaceous, 130 million years ago, you see that the northern hemisphere, so Asia, Europe, and North America, have largely separated from the southern continents, the Gondwanan continents that I mentioned. And you can see there the shapes of the southern continents beginning to form. Here in the middle of the Cretaceous, you can see again, the continents are rifting apart. So this is what I mean by rafts. So dinosaurs living on rafts. The rafts are the continents. And by the end of the Cretaceous, you see a relatively modern world. Sea levels were much higher, so you can see that a lot of the continents were inundated by seaways, including Africa, and here, Western North America, here in Colorado, we were underwater. And note that India, which we associate today with Asia, South Asia, is all the way down, nestled between Madagascar and Australia and Antarctica, so really far south. And to understand what we call biogeography, so the distribution of plants and animals, we look at different groups that were restricted to these rafts. So we want to look at animals that weren't swimming, that weren't flying, that were really stuck on the raft that separated apart. So one of those groups are sauropods. And so for the discussion today, we're going to focus on a group of sauropod dinosaurs or long-necked dinosaurs called titanosaurians. And then the other two groups are theropods. So the big meat-eating dinosaurs, and in particular, we're going to talk about abelisauroids. So these weird little short-armed, big-headed, often ornamented on the head types of meat-eating dinosaurs, and then crocodiles called notosuchians. So notosuchians are a southern radiation of crocodiles that were mostly terrestrial, and so we think that they had a difficult time dispersing or traveling between the continents. And a lot of them had really weird features that we'll talk about today, including herbivory, so plant-eating crocodiles, omnivory, so they had molars for grinding teeth, grinding different plants with their teeth. A really wide array of different fossils that we can look at to track these continents through time and see how they're related. So to do that, we need to review some of the continents and their history. So this is the fossil record of South America during the Mesozoic. Each of these red bars represents different dinosaur-bearing rock units. And so if you look at the time scale at the top, each of these red units gives us a pretty clear picture of what was going on the continent of South America between 130 million years ago and the extinction of the dinosaurs 66 million years ago. So we have multiple dinosaur faunas from places like Brazil, Patagonia in Argentina, also some fossils in Bolivia and Uruguay. So a really rich fossil record for which we can compare our other dinosaur finds that we've been making here at the Denver Museum. One of the ones I just wanted to highlight really quick was in the news earlier this summer. This is a really cool dinosaur that I don't think got enough attention, called Spectrovenator, spectro meaning ghost, so it's the ghost hunter. This is a really cool fossil, almost complete skull and really neat parts of the postcranial skeleton, so the legs, the vertebrae, the hips. And it's told us a lot about this group of dinosaurs called abelosauroids that I mentioned earlier, these dinosaurs with really small forelimbs and really big heads. So to get to some of the discoveries we're making here at the Denver Museum, we need to travel all the way to the island of Madagascar. So for those of you who know where Madagascar is, or who don't know where Madagascar is, it's off the east coast of Africa. And it's been sitting in that position really since the time of the dinosaurs. It hasn't moved around a lot. And the only fossils we have from this time period are from the very end of the Cretaceous. So there's a little red bar there in the upper right. So we only have dinosaurs from the last few million years of the Cretaceous. And that's all from a project that was started in 1993 by a DMNS curator, Dave Krause. I was lucky enough to join the project in 2005. And so for the last 15 years, I've been out to Madagascar digging fossils with Dr. Krause and other teams from around the country and uncovering one of the best preserved Gondwanan faunas anywhere in the world. And that includes amazing birds, some of those bizarre crocodiles I mentioned, even fossil mammals. So down in the lower right, there's a fossil mammal of a bizarre group of mammals called Gondwana. And then of course the sauropod and abelosauroid theropods. So really cool fossils. And these discoveries have led to several hypotheses. So different ideas about how the dinosaurs from these continents were related. And at first, back in the late 90s and early 2000s, we thought that the Madagascar dinosaurs were most closely related to South America. And that led to a hypothesis we call Africa first, which postulated that Africa broke away from the rest of the continents before all of the others. And that means there were lingering connections. So dinosaurs could travel from South America to Antarctica, across Antarctica, which at this time was ice-free and very warm, and all the way up into places like Madagascar and India. So these were all closely related. Further research, and as we found more fossils, which is always the case, tested this hypothesis, and it has resulted in a new hypothesis, something that we call Indo-Madagascar Relictualism. So this means that the dinosaurs that are on Madagascar and India were basically stuck. So the closest relatives of these crocodiles and dinosaurs lived about 120 million years ago when Madagascar was still connected to Africa and the other continents. And so this is a really good example of that rafting hypothesis. And what that means is the crocodiles and dinosaurs that were stuck on the raft of Madagascar were free to radiate and evolve into really bizarre forms. And one of the coolest and my favorite is this crocodile called Simosuchus. So Simosuchus is pug-nosed, so it has a really short snout. If you look at the teeth there on the left, so that's a nose-first view of the skull of Simosuchus, the teeth kind of look like little hands. And those teeth are most closely compared to reptiles that live today. And those reptiles eat almost exclusively plants. So it's an herbivorous crocodile. And then just last week, we announced a new bird. So one of my colleagues, Patrick O'Connor at Ohio University, described this new really bizarre bird called Falcatakili, which is a reference to his really bizarre beak. And so at this time, birds are just on the scene. There's a variety of different types of birds. And this is one that's experimenting with a bizarre beak or bill shape that's almost like a toucan. And the most unusual feature of this is, notice in the skull drawing at the bottom, it still has teeth at the very tip of its beak. So imagine a toucan with sharp teeth at the very front of its bill. About 10 years ago, a colleague and I wanted to explore the origins of these bizarre fossils. So if dinosaurs were trapped on the raft of Madagascar, what were they like? And so to do that, we had to go back in time and look for rocks of older rocks from older time periods in Madagascar. And one of the places that we went to was the Mbila Bay Basin, or the Diego Basin, which is the very northern tip of Madagascar. And rocks in this area are dated somewhere between 90 and 88 million years ago. And we spent several weeks walking around the forest, It was a really beautiful place to work, but not really great for finding fossils. But here at a old dried up waterfall, I noticed a little bit of bone sticking out of the wall. So it's hard to see. I'll use my cursor. This little black bit of bone revealed part of a dinosaur that was preserved in a cliff. So as you might imagine, digging a dinosaur out of a cliff is really difficult. Here, a colleague of mine, Liva Ratsimbaholisone, one of the paleontologists in Madagascar, is helping me excavate into the sheer cliff wall using just pickaxes. So it took us quite a while to get this dinosaur out. And what we recovered were different parts of the backbone, so 7 different vertebrae, and a couple of ribs of a dinosaur that we named Dahalakili. And Dahalakili is notable in that it's one of the abelisaurs that we talked about. And it lived at a time when Madagascar and India were still connected or just beginning to separate. And so we think this is one of those ancestral forms of abelisaurs that lived on Madagascar that gave rise to later dinosaurs like Majungasaurus in the latest Cretaceous of Madagascar. But that's all we found, and it doesn't seem like there's a lot of potential if we were to go back to this area for finding more or different types of dinosaurs. And so I expanded my search a few years ago into south and western Madagascar. This is an area that we call the Morondov Basin. And the Morondov Basin is really well known for its fossil ammonite. So if you've ever been to a rock shop, if you've ever collected fossils or bought fossils of ammonites, a lot of them come from western Madagascar. Ammonites are those coiled shells with the different chambers. And some of the most beautiful in the world come from western Madagascar, from ages that are ranging from about 120 million years ago to about 80 million years ago. So a really wide range of possibilities for dinosaurs. And luckily we found some. And so this is a dinosaur as it was discovered out in the middle of a burnt grassy field in Madagascar, in western Madagascar. And after we peeled back the sod, so all the grass and all the soil that was on top of it, we were able to uncover a really cool portion of a gigantic dinosaur. And so the green in the middle here, this is the femur or thigh bone. This is the shin bone or tibia. This is the fibula. And we have most of the tail and even parts of the foot and hips. And what's really neat about this dinosaur is it's huge. So that femur is about 7 feet long. It's almost 2 meters long, which puts it in among some of the really largest dinosaurs that have ever existed. And what's interesting about that is scientists had hypothesized that dinosaurs that got trapped on islands like Madagascar, probably got small because of limited resources. And this is a dinosaur that flies directly in the face of that hypothesis. We're currently cleaning the fossil here in our labs and with some of our partners around the country. It's really slow going. So far, we've cleaned a good chunk of the tail and the leg, but we still have several more of these dinosaur blocks to clean up before we can give this dinosaur a new name and see where it fits in the grand scheme of Gondwana biogeography. I'm going to shift now to Africa, which has the opposite problem from Madagascar. So remember, Madagascar, we had fossils from the very end of the Cretaceous and a few fragments from some other time windows. Africa is known mostly from dinosaurs from the early part of the Cretaceous into the middle. So each of these bars represents a time period or time window where we have dinosaurs going all the way back to the late Jurassic, 155 million years ago, and into the middle of the Cretaceous to about 90 million years ago. These sites are known from mostly the Sahara, so the desert areas of northern Africa. All these red dots represent those localities. And a lot of you might be familiar with this famous dinosaur that's been in the news a lot for the past several years, Spinosaurus, which is known originally from Egypt, but also from Morocco, from a time window right here in the middle of the Cretaceous, somewhere around 120 to 100 million years ago. And it's been in the news a lot because of really neat revelations about how Spinosaurus lived. So it had a really tall tail that probably propelled it in the water, short limbs, which are unusual for a meat-eating dinosaur, and conical teeth that look most like a crocodile. So we think now, based on some of this new information, that Spinosaurus ate mostly fish and things that lived in the ocean or nearshore environment. But I want to talk to you about some of the new discoveries that my colleagues and I have been making in Africa. And to do that, we have to first travel to Tanzania. And this is an area where my colleague, Pat O'Connor, has been working for several decades now, in the red rocks that you see here on the right. We still don't have a really good idea of exactly what age they are. They might range from anywhere from 100 to 88 million years ago or even younger. But they're really telling us a cool story about Gondwana. And one of the coolest fossils so far from these deposits is a crocodile called Pakasukas. And Paka means cat in Swahili. And the reason we named it the cat crocodile was first for its size. It's about the size of a common house cat that you would have at home. And then if you look at the skull in the lower left, it has cat-like features. So it has a canine at the front of the mouth, and it also has chewing molars at the back, or shearing molars, very similar to your house cat. And so this crocodile tells us a lot about what crocodiles were doing at the time, processing their food. They were able to get more energy out of the food than a crocodile that just gulps its food today. Some of the other fossils we found include sauropod dinosaurs. There have been 3 different species described from these deposits, including this one called Ruqua-Titan. And what's really interesting about the fossils from this area is, rather than being closely related to what we know from the north, this fauna from the Sahara, is that it seems that some of these fossils, like Pakasukas and Ruqua-Titan, are more closely related to dinosaurs that existed in the south or the southeast. And so we're starting to see a picture where Africa itself might have 2 different dinosaur faunas. There is a crocodile that we recently described called Ruqua-Sukas, one of these Notosuchians, that is closely related to the northern form. So there could have been some dispersal back and forth between the 2 regions, but overall it's quite different. We don't see things like Spinosaurus in the south, which is unusual. What about the late Cretaceous? Well, each of these dots represents little time snippets where individual fragmentary fossils have been found. So that means a single bone of a dinosaur here or a single tooth there. And these sites are distributed across the continent of Africa. So each of these red dots represents one of these places that fragmentary fossils, so little pieces of dinosaur, have been found. Recently, work with one of my colleagues in Egypt, Hisham Salam, has recovered some really amazing, more complete dinosaurs from this time period. So 75 million years ago, Egypt was a coastal area, so the oceans had inundated much of northern Egypt, but we get fossils of dinosaurs and crocodiles that lived along this coast. And that includes this new find called Mansurosaurus. And what's really neat about Mansurosaurus is it's most closely related to fossils in Europe. And so this leads to a new hypothesis, at least for African finds, called EuroGondwana. And that means that some of the European dinosaurs were able to disperse across the sea into northern Africa, and possibly some of the African dinosaurs, or northern African dinosaurs, were able to disperse north into Europe. We still don't know about the other parts of Africa, which is why I've highlighted them in orange, but it's a really neat hypothesis. And it was just supported a few months ago by a find in Morocco from the very end of the Cretaceous of a dinosaur we are familiar with from the Colorado area, a duck-billed dinosaur, this one called Ajnabia. And this was a dinosaur that lived in Morocco, but was most closely related to duck-billed dinosaurs that were living at the time in places like Spain and France. So early crested duck-billed dinosaurs. So again, a really good support for that EuroGondwana hypothesis. But again, all of these are fragmentary. So to really understand this, we need to get a fauna. And a fauna is a dinosaur-bearing rock unit where you can see multiple different types of dinosaurs and other animals that lived alongside them. And one such place I think exists, and this is based on work I've been doing in Kenya, in very far northern Kenya, since 2004. So for the past 16 years, I've been working on dinosaur fossils from the Turkana region. It's an area that's really well known for anthropological finds, so our early human ancestors. But there's one spot in Kenya where Cretaceous rocks have been brought to the surface. And early explorers of this area that go way back into the 1960s and before found dinosaur fossils here, and they assumed, based on this fossil in particular, that Spinosaurs lived in the area. So there was a link with some of those faunas from Egypt and Morocco. Turned out, after we got this fossil out and cleaned it up, it represents a really unique type of crocodile that we don't see anywhere else. It has a really big, massive lower jaw with huge crushing teeth. This is essentially a hyena type crocodile that was able to crush and swallow dinosaur bones whole, probably. We also get other crocodiles that show that this was a coastal area. And most importantly, this type of crocodile called a dinosaur gives us a sense of the age. And so this type of dinosaur lived at the very end of the Cretaceous. And so we think that the rocks that these dinosaurs were deposited in go back to about 67 or 66 million years ago. So the same age as T-Rex here in North America. The dinosaurs are really exciting. So here's an upper arm bone or humerus of a titanosaur sauropod. And so far, the sauropod story tells us some really interesting things about the biogeography. One of them is that there are relics. So just like in Madagascar, where you have dinosaurs that have been abandoned and left on the raft by themselves for a very long time, we have the same thing going on in Africa. So here's an early titanosauriform, so a very old type of titanosaur, mixed in with really advanced types of titanosaurs that are most closely related to dinosaurs in South America. So we have evidence of relics, so dinosaurs that lived in Africa for a really long time, but also dinosaurs that might be going back and forth with South America. And then of course we have our friends, the abelisaurs, the little short-armed meat-eating dinosaurs. And this is based on a ton of different fragmentary finds. This is the lower right jaw of a smallish abelisaur, and we also have really cool bones from a big dinosaur, probably getting close to the size of a T-Rex. And so for the very first time, we have a fauna from the very end of the Cretaceous, represented by at least 8 different types of dinosaurs and 2 different crocodiles. And what it tells us is Africa was a really complex time, or complex place at this time, where we had dinosaurs probably going back and forth, at least early on, from South America, some from Europe, so supporting a EuroGondwana hypothesis, but also dinosaurs that were unique to Africa, just like the dinosaurs of Madagascar and India that were unique and bizarre in their own ways for those land masses. So Africa was in a way a crossroads for Gondwana. And so I know that I crammed a ton of information into this talk, but I'm really excited about these finds. And I think you'll see over the next few years as we continue to dig these sites, as we release some of the new names of the dinosaurs and show how they're related, there's going to be a lot of new information and a lot of exciting discoveries coming out of Africa and Madagascar that teach us about how dinosaurs and ecosystems changed as they floated apart on rifting continent rafts. So with that, I'm going to end my talk, and I'm really excited to get some of the questions that you have about dinosaurs.
Hello again, Joe. Fantastic talk. We do have a few comments and one question so far. So Billy says, Joe, this is awesome. Thank you for doing it. Thanks for watching, Billy. We have a comment from Mina who says, I want a pet Pakasukas. And I said, I do too. They're adorable.
Seamasukas would be a good one too. It's about the size of a small dog. And it only plants, so you could just throw lettuce down to it.
How cute. And then we have one question from Felicia who says, wow, what can we learn from the way dinosaurs lived that can benefit us today?
Yeah, that's a really great question, because that is really the reason paleontologists go back in time to study fossils. Being able to answer questions about today's world and the world as it's changing, and getting an idea of where we're headed in the future is why we do this work. So by studying dinosaur ecosystems, we essentially can see really long-term experiments that have already been run by Earth history. And so we can see what happens to a dinosaur ecosystem when climate changes. We can see what happens to an ecosystem when it's isolated on an island. And so we can learn a lot about how evolution works, but we can also understand how ecosystems handle change. And right now, as you know, our world is going through a lot of change as human population increases, as the climate is shifting and changing. And so by going back in time, we can see how our world around us is changing and how life is going to react.
Awesome. I see 2 more questions. How about we take these 2 and then we'll head on out. And if you have any more questions, everyone, just leave them in the chat and I'll make sure Joe gets them so he can answer them for you. So we have our first question from Billy, who says, fantastic. How did you get those huge fossils back from Madagascar? That must have been one heck of an undertaking. Great question.
Yeah, thanks, Billy. Yeah, so those huge dinosaur fossils that I showed you, so that big 7-foot long femur and all of those tailbones took several seasons to get out of the ground. So we had to use rock saws and lots and lots of plaster. And we were about 20 miles from the nearest road, which meant we had to get really inventive on how to get those fossils to the nearest road where we could get them on a truck. And to do that, we hired a lot of the local community to help us. And what they did is they showed up in huge teams to help us move these fossils with cows. And so we actually put them in ox chariots, and cows carried them out to the road. And so it was a really unique, probably the most unique way I've ever moved a big dinosaur. Here in North America, we get to easily get them out with helicopters and interns, but out there we got to use cows.
Wow, that is amazing. Wow. And you kind of touched on this with your last answer, but Becky asked, and how about we let this be our last question? She asked, what materials do you use to restore the fossils in order to display them at the museum?
Yeah, so a lot of those fossils I talked about were based on fragmentary finds. So a jaw here or a part of a skeleton. And to understand what the rest of the skeleton looked like, we have to compare it to more complete relatives. So what we do is often we'll take a really complete dinosaur that's closely related and then fit our dinosaur bones into that. And so for the example of Dahalakili, the dinosaur from northern Madagascar that was only known from 7 vertebrae, we use its close relative, Majungasaurus, and we slot those bones in, and then we get a really good picture of what it probably looked like based on its close relatives. And so a lot of this work is done in our labs here at the museum, and also using partners who do this type of work all around the country, where they can build a skeleton using all of this information and using sculptors and artists. So it's a really neat collaboration with artists, scientists, and fabricators, people who are really good at welding and things like that. So it's a really neat process to bring you a fossil that's found on the tip of northern Madagascar to a display that you see in a museum.
Wow. And actually, can't we come by Prehistoric Journey and see you and your team work on some fossils? Is Pop still up? Pop's the Triceratops still in Prehistoric Journey right now?
Yeah, so if you come to the museum right now, we have Pops the Triceratops. This is the Triceratops that was found up north of Greeley in Weld County. Pops is on display in our window being cleaned. And so you can see the very early stages of cleaning a dinosaur skull, big Triceratops skull. And just across from the window, we have some of these Madagascar fossils that I talked about today. So we have fossils of crocodiles, meat-eating dinosaurs, and sauropod dinosaurs on display right behind our prep lab window.
Awesome. Well, how about we end with that? End with, hey, come and look at us clean some real fossils at the museum during your next visit.
Yeah, please come and visit us.
Awesome. Everybody, we will be back next Thursday with Science Division Live. So we'll see you then. Thank you again, Joe.
Yeah, thank you. Thank you, everybody. It was good to talk to you.